So today we're going to talk about the law of sines and cosines. Now I'm assuming that you guys have seen this before already, and so I'm not going to derive the formulas. This video is just focused on how to use the formulas. What are they and how do we use them? But real quick, a quick note about notation. It is standard in math that when we are labeling a triangle, we use capital letters to represent the vertices and corresponding lowercase letters to represent the sides. So this side is opposite angle B, so we use a lowercase little b to label this side. This side is opposite angle C, so we use little c. And this side is opposite angle A, so we use a little a. So just kind of keep that in mind as we're going on. So then when we look at these formulas are based on using that notation. So when we say a little a and a big A, and a little b and a big B, and a little c and a big C, these are opposites of each other in the picture. So law of sines, this is a formula for law of sines. We have two different versions. Just memorize one of them. The other one's really easy, just flip it. But this version, the reason why we have two versions, this one's easier to use when you're trying to find a side, because your unknown is on top. In general, in math, if you can put your unknown in the numerator of a fraction, it's easier to solve for. And then, so this version on the bottom with the angles on top, it's most useful when solving for an angle, because now the angles are on top. And law of sines we use when we're given AAS or ASA. And I'll explain that. If you're not sure what that means, I'll explain that when we look at an example. Law of cosines is this formula. Now this formula, you got to be a little careful. It's a little more obvious, so we're talking opposites here. Here, though, everything's all kind of jumbled. The key is there's only one angle in the formula. And this is a capital A. The only little a in this formula is on the other side of the equation. So this is where you got to be careful. The a's you have to make sure you have right. So the angle and its opposite side have to go in these locations in the formula. But then the b and the c are the other two sides, and they're interchangeable. The b and the c are just being added here, and it doesn't matter what order you add in. And the b and the c are being multiplied here, and it doesn't matter what order you multiply in. So you have to get side A correct, but then the other two sides are interchangeable. Now, honestly, I would just memorize this version right here, this formula. This is solved for the side, though, so it's definitely going to be easier to use when solving for a side. If you're solving for the angle, then you may want to rewrite this solved for the angle. Don't try to memorize this. Just take this equation and isolate the cosine A. So we'd have to subtract off these two terms. So we'd have a squared minus b squared minus c squared. That's the numerator. And then all of this is being multiplied by cosine A. So you'd have to divide by that. So it's easy to go get to this equation from this one. So honestly, I would just memorize this one. And then if you need the angle, just quickly solve this equation for cosine A, and then you have this version. And law of cosines you're going to want to use when you have SAS or SSS. Now both of these, I should have started with this, both of these equations are used to solve any triangle. Before today, we reminded ourselves how to solve right triangles using SOHCAHTOA, sine, cosine, tangent, opposite, hypotenuse, adjacent. But if you don't have a right angle, we call those oblique triangles, and you can use these two formulas instead to solve the triangle. So let's just look. We're basically going to look at 3 examples, and then I'm going to show you a trick you can do with Desmos to help you calculate stuff to make your homework a little less tedious, and then that's it. So here's the first example. Solve the triangle. And the original triangle only had the purple stuff. So we were given angle M is 42 degrees, and we were given these two sides were 7 and 5. So the first thing you got to do is figure out which formula you're going to use. And we were given side, angle, side, or SAS. And if you look at above in the notes, that's law of cosines. So that's how we know we're going to start off using law of cosines. Now, you have to deal with opposites then, and the only angle we're given is 42 degrees, so that must mean we're going to have to find side M first. So again, here's the formula, and remember this angle and this side are the important ones to get right. We're given angle A is 42 degrees. That means A must be the same thing as little a is the side we're looking for, which is M. And the other two sides are interchangeable. So I could have put the 7 here and the 5 there, or the 5 here and the 7 there. It wouldn't have mattered. So I just plugged all those in. And now this is actually pretty straightforward because you just type all that into a calculator or into Desmos. You get this approximately, take the square root, and there you go. There's your little m. So you just have to know how to plug into the formula. Now once you get this, then we have to find two other angles. And it doesn't matter which angle we find. So I just went ahead and found n. Now I could have used the law of cosines again. And I have an example later to show you how to use law of cosines to find an angle. This was using law of cosines to find a side. So don't worry, we'll look at that. But what if I want to find angle n? And I want to use law of sines, because at this point now I can switch. So I'll do it. Law of sines, remember, is about opposites. And we're finding an angle, so I'm going to put the angle on top. So I'm going to start with sine of n, which is opposite 5. And then the only other pair of angle side that are opposites that we have are the m's. So sine of m over little m, and we just found little m. Now to get the n by itself, multiply both sides by 5. And to get the n by itself, we're going to take the sine inverse. And then literally you can type all this in, and there's your n. And once you know that, it's easy to find the other angle because you just subtract from 180 degrees, and there's your answer. So that's our first example. Now sometimes you're not given the triangle and you'll have to draw it. So in this case, we were given the 40 degrees, the 53 degrees, and the 9. So we know we have a B, C, and D. I just drew a triangle with a B, C, and D. We know angle B is 40 degrees, angle C is 53 degrees, and little d has to be opposite angle D, so I knew this had to be a 9. This is angle side angle, so this is ASA, which means we have to start with law of sines. But let's actually find this missing angle first, because it's just so easy. Just subtract from 180, you get that missing angle. And now, let's go ahead and find B and C. It doesn't matter which one you do first, so I just chose B. And again, law of sines is all about opposites. And this time, because I'm looking for sides, I'm going to put the side on top. So B over sine B. And the only other pair of opposites that I have right now are the D's. So B over the sine of B is equal to little d over the sine of big D. Multiply both sides by sine of 40 to get the B by itself. And type it into a calculator and you get B. And then I just did the same exact thing for C. C over sine C is D over sine D. And we have all of those. Multiply by sine of 53 to get the little c by itself. Plug it into a calculator and you get that answer. Yay! Okay, let's look at our last example. Let's look at this guy right here. So, we are given little p, little q, and little m. So if we draw a picture, we know we have angles M, P, and Q. Opposite big M is little m. Opposite big P is little p. Opposite big Q is little q. So I just labeled all of those. We can see we have side, side, side. So it is law of cosines. Now we're already given all three sides. We're looking for the angles. So I'm going to use that version of the cosine formula, law of cosines, that solved for the angle. And again, let me go back up there super quick. Remember, it's about the opposites. Whatever angle you're working with, that's what you have to start with in the numerator. Start with that corresponding side. But then subtract off the other two sides, divide by the other two sides. So that's what I'm doing right here. To find cosine of M, it's going to be little m squared. These have to match. Subtract off the other two sides, divide by the other two sides. Same thing for cosine p. Start with little p. Subtract off the other two sides, divide by the other two sides. Subtract off, or as for cosine q, we're going to start with little q and then subtract the other two sides and divide by the other two sides. So I'm going to show you actually what I did on Desmos to make this a little bit easier. And like I said, just less tedious for your homework. This isn't that hard to type in, but yeah, type all this in. And once you get that, then you do the cosine inverse of that. So let me go ahead and just show you Desmos real quick. All right, so here we are in Desmos. Now, hopefully you guys can just look back at the homework, the notes that you have. So we were trying to find cosine m first. What I'm first going to do is just tell Desmos what my letters are. It just makes life easier. P is 12. And if you do this on your Chromebook, you can use your keyboard, which makes it even easier. Q equals 14, M equals 20. And Desmos does know the difference between the lower and the lowercase letters and the uppercase letters. So make sure you use the correct case. So then we had written on our notes that cosine m is, and it was, oops, if I can get there, m squared minus p squared minus q squared over negative 2pq. And notice as soon as I finished it, it's evaluated that expression for me, which is awfully nice. And then the next part I would have to do to find the angle m is I'd have to do the cosine or cosine inverse of both sides. So I can do the arc cosine of, and this is where I'm using my tablet, and my keyboard on my tablet doesn't copy and paste for me. But ideally I could just go up here, highlight, copy, come down here, paste. It would paste that expression and work it out for me. But unfortunately for this, I'm going to have to type it over again. But it's not that bad. Negative 2pq. And there we go. Now something looks a little funny about this. I mean, that's supposed to be an angle measure. I mean, you might get a small angle measure. But 1.75, that's really small. Double check. The mode of Desmos defaults back to radians. I just clicked on that wrench in the upper right hand corner. Make sure you're on degrees. And oh, look at that number, 100.28. That looks so much better. And sure enough, so think about these numbers. Negative 0.17, 100.28. Look at that. Negative 0.17, 100.28. That's where I got these values from. I just used Desmos. Now, here's where the really nice thing about doing that way. Now for angle P, I want to change this formula, but all I need to do is I got to start with little p and subtract off m and q and divide by m and q. And look, I've got my new value right there. And again, I could just copy and paste this down into my arc cosine, but I can't on this keyboard, so I will just go ahead and quickly edit it. But there I have it. I was able to reevaluate it very quickly. So 0.807, 36.1, 0.807, 36.1. Yay! And then I did the same exact thing for angle Q. If I go back there, this time I want to start with little q, subtract off m and p, divide by m and p, and now I've got these new values. Think of my angle 43.5, and sure enough, 43.5. So it just makes it really nice. I would use Desmos to help you out with your homework. So anyway, that's it. Your homework's going to be very similar to this. So good luck and have fun.